All right, hello everyone. We're going to give everybody another minute or two to join the meeting. We do have a little bit of extra time in our agenda because clearly Tim and I do not know how to do math and tell the difference between 100 minutes and 50 minutes.
Well, that's why the last presentation has an unknown number of minutes on the agenda, right?
Yes.
Speaking of that one, I figure that some of the discussion that goes with my draft would also go with Paul's presentation. So maybe it makes sense if after my draft, we only do questions about the draft. And then we'll let Paul present, and then we go all in on the use cases, etc.
Yes, that's actually what we were thinking with that extra time. And as long as you're good with that, we'll just do specific questions after your presentation, and then we'll have an open discussion after Paul's.
Perfect.
All right, everyone, let's go ahead and get started. I want to welcome everybody to the last session of IETF 108. So hopefully everybody is still awake and sane from a week of online meetings. I'm Brian. I have Tim flying co-pilot with the slides. Want to go to the next one, Tim? There we go. Just to make sure everybody's aware, we're still operating under the note well, and although the various rules apply for declarations and things like that, and if you haven't read all those BCPs, do that after this meeting. Next slide, please. All right, the nice thing here is that we're not passing blue sheets around, we're not signing in via WebEx chat rooms, we're not doing things in Etherpad. The nice folks over at MeetEcho are going to harvest the attendees from the roster on MeetEcho. Quick run through what we're going to do today. First one is dealing with the agenda. We're going to do a quick update on some of the current workgroup documents, and then we'll slide into a discussion of some of the current work that's going on, and then we'll get to discussions of a couple of new workgroup items that are that have been proposed and either just somewhat discussed on the mailing list or just popped up at the very last minute to help frame some discussions that actually started over in DNSOP, if I caught all of the various discussions correctly. All right, document updates. So first one on the list is 7626biz. I know a couple of you have asked, at least me in private, and I know there's been a couple of queries on the mailing list as to what's going on. It's sitting in revised ID state. And right now, what we've been doing is having discussions between Tim and I and Eric and the authors. There's been some questions about some of the changes that have gone into the document, and we're trying to make sure that what the document is actually doing is reflecting the consensus that came out of the working group, and that changes that go in after that have consensus for support within the document. So that's going to be a piece of work that the chairs and our AD are going to have to deal with. One thing that I will point out, we are going to have a change in authors. I want to thank the authors, especially Sarah, for pushing this document as far as they have. Right now, that editing that I just mentioned, as far as making sure that we're including the document, the content that has consensus, is actually being worked on by Tim. So I'm going to remain the document shepherd, and we'll be working with Eric to make sure that everything is good to go. And Tim disappeared. I can talk through some of these without the slides. The other main thing that was on the document status is the BCP. That is now in the RFC editor's queue. Some of we had some minor edits to resolve IESG comments during their review, and so that all has been approved, and we now have that in the RFC editor's queue for processing. So the next thing for us is to wait for them to come back with any issues from an editorial perspective. And the other active document is our phase 2 requirements document. Tim is actually working with the authors to make sure that we're making progress on this document, but we don't have an update for this meeting in particular. All right, next one, Tim. So this is the agenda for the rest of the meeting. I'll take a minute here to see if there are any changes, updates, modifications that people want to make to the agenda before we move forward. If you do, speak now. Okay, so then we'll go on to the presentation of the zone transfer over TLS. Sarah, are you presenting?
I can do if you'd like me to.
Somebody has to.
Let me. So I think that's your screen, not mine, still at the moment.
Let me see.
Okay, how's that looking?
Yep.
Excellent. All right, thank you very much. Okay, so I'm going to talk today about the zone transfers over TLS draft that is proposed. I'm presenting today, but my co-authors on this are William Turrup, Shivan Sahib, Pallavi Aris, and Alison Mankin. So a little bit of background to start with. Today, all zone transfers take place in clear text. So it's possible to collect the contents of a zone by passively monitoring that on-the-wire transfer. But there are lots of scenarios where the owner of a zone will desire privacy for the contents. And this could be because it might contain personal information. It might contain information that's very sensitive for an organization in many different ways. Or there might be regulatory or policy reasons to keep it private. And these were some of the factors that motivated the development of NSEC 3 and NSEC 5. Specifically, ZOT is designed to maintain privacy when the zones are transferred between entities. So stop collection of zone data during the transfer. How do we propose to do that? Well, we're proposing that we encrypt the transfers, both AXFR and IXFR, using TLS as a transport. The draft to propose this was adopted by DPRIVE back in November 2019, and we've been working on it since then. As I've mentioned, the primary use case that we have here is confidentiality. However, the use of TLS opens up some other considerations. Firstly, we want to point out that using either single or mutual TLS can provide complementary authentication to existing techniques, mainly TSIG and ACLs, and we discuss the characteristics of each of the types of mechanism in the draft. Secondly, what we've noticed is that many of the existing implementations, when they do transfers, are suboptimal. The reasons for this are probably historic, partly because they had to be backwards compatible with very early implementations. But we've seen in a number of cases that the secondary will open up a single TCP connection, do one IETF exchange on it, and then close that connection, and then open up another connection very quickly for another transfer. So we think there are improvements that can be made on that. A quick picture to show you the basics of what we're proposing. On the left-hand side, we have how a IETF would work over TCP today. So obviously you have a notify, an SOA query, and then in the case of IETF, a set of requests and response, which typically today actually happen over TCP. On the right-hand side, we have what we're proposing for ZOT-based IETF. And in this case, what we're proposing is that the IETF requests and responses are guaranteed to happen encrypted. So all of those exchanges must happen on a TLS session. Optionally, in fact, we recommend that the SOA is also sent over the open TLS session. However, it's not a must, it's optional, but since there's a session open, it makes perfect sense to actually use it for the SOAs as well. So we did an update in July of this year, that's the 02 version, and it contains a number of fairly substantial changes to the version of the document that was adopted back in November. Probably the most significant one is that in this latest version of the spec, we introduced the use of ALPN for transfer-specific connections. So ALPN is an application layer protocol negotiation. It's a parameter that's sent from the client to the server in the TLS handshake so that the client can indicate which protocol that connection will subsequently be used for. And in the 02 version of the spec, we introduced a new ALPN option called ZOT, and we refer to connections that are initiated with that parameter as ZOT connections. And the important thing to note here is that we then limit which queries can be made from the secondary to the primary on such a connection. And we limit them to IETF, AXFR requests, and SOA only. So what's the rationale for this decision? Well, looking back at some of the earlier specs, we noticed that in RFC 5936, which is the draft which re-specifies AXFR, that it has a statement in there that a TCP connection can be opened for AXFR traffic, and that afterwards non-AXFR session traffic can also use that open connection. Now, that makes sense in a TCP context, but when you're considering using TLS, what we have to remember is that there is currently no RFC that specifies recursive to authoritative encryption. And I'm going to call that A dot here to distinguish it from stub to recursive encryption. So we don't have a specification. There's still a lot of work to do on that, and we don't know when and if we're going to arrive at consensus on that. So what we chose to do with the ZOT specification is to remove any assumption or dependency on what the solution for A dot might look like, and also remove a dependency that an authoritative implements that solution in order to support ZOT. So the ALPN lets us do that. It decouples those two properties. So it means that an authoritative doesn't have to directly or indirectly support DOT in order to provide ZOT, zone transfer over TLS. And what we say in the specification is that on a ZOT connection, the server should refuse queries of types other than the subset specified. And I want to make clear that none of this precludes a future development in the specification supporting a mixed mode. We are just keeping the specification in this document tight so that it's simple and self-contained. One other thing we noticed in working on this draft is we went back and reread RFC 7766, and that's the document that specifies the implementation requirements for DNS over TCP. And there's a section in there which talks about issues around the recommended number of the recommended number of connections between servers and clients. And the text in there currently says, in normative language, that there should be one connection for regular queries and one for zone transfers for TCP. But it then goes on to say that there should be one connection for each protocol that is being used on top of TCP. Now, I was an author on 7766, and I'm afraid remembering the rationale for that distinction escapes me. If any of the other authors know it, please do make a comment on that. But what we've done for the ZOP specification is we've gone back and done a minor update to 7766 simply to say that all transports, TCP and those on top of it, should behave the same and should use one connection for regular queries and one for zone transfers, so that the other protocols are not limited to having a single connection to do everything. So the other thing that the O2 version does is it minimally updates RFC 1995. When you go back and read 1995, it's easy to see it was produced in the days when TCP really wasn't considered a first-class transport for DNS. It was published in 1996, and so it's very basic in how it talks about connection reuse. So we have a simple update saying that it should follow 7766 in terms of connection reuse, pipelining and out-of-order responses, and all those things which are now the recommended options on session-based TCP. We have a bit more detailed discussion about RFC 5936, but we currently don't update it. But what we do for ZOP specifically is optimize the mechanisms compared to the specifications on TCP, because ZOP doesn't have the burden of backwards compatibilities. So some of the dustier corners we can optimize away when we're describing the pure ZOP case. One of the other things we updated in O2 was the discussion of padding. We've limited the discussion now to two areas. One is the goals of padding, in other words, what problems is padding trying to solve? And secondly, what we wanted to do was identify any minimum requirements that need to go into a base protocol in order to flexibly support any future padding policies we might develop. The one thing that's in the draft that we've identified is that for some corner cases, there might be a need to support the exchange of empty AXFR packets. So those are packets that will have no RRs in them, but they will have an EDNS 0 option, which can be padded. And this is really just about future-proofing the options around padding. That's why it's mentioned in this draft. What we have clearly said in this draft is that any further work on transfer traffic analysis or the development of specific padding policies will be done in another draft. We have an initial version of that draft, but I would say if there's anybody in this session who is interested in collaborating on understanding the analysis and developing padding policies, please do get in touch with the authors, because we'd be very happy to work together on that. Okay. Since we published the O2 version, we have had one very in-depth review on the list. Thank you very, very much, Tony Finch, for that. It raised a lot of excellent questions. And we've had a number of quite in-depth off-list discussions, and this has raised some more questions and comments which we intend to address in the next version of the draft, and I'll skip through those on the next couple of slides. One of the things we need to do is to go back and slightly rework how we propose the updates to the original specifications for RxFR and AXFR. And in particular, although it's there in a implicit sense, we just want to add some clarifying text around what happens when those two mechanisms are sharing a connection and you may need to intermingle the responses. So that's really just clarification about that behavior. Another topic that came up was around the discussion of transfer rates or limits on concurrent AXFRs. Now, neither of the original specifications discuss this at all. It's not mentioned in 1995 or 5936. Bind has some controls already that let you limit the number of concurrent AXFRs, I believe one for the total and one for the transfers per NS. So a question that was asked is, does ZOP give us an opportunity to add some further signalling? Is it useful for a primary to be able to signal to the secondary why it is refusing requests for transfers? Because there certainly are cases where the primary might choose to throttle the transfers, and the thinking is that this could be useful in that if a secondary has multiple primaries, it could then choose to switch to another one, and that might provide a very crude form of load balancing in scenarios where there are multiple servers involved in these transfers. So we'd be interested on feedback as to whether people think this is useful and what this should look like. Another topic that came up and needs to be addressed in a bit more detail in the draft is around what I'm going to call usage profiles, in order to give them the same name that was used when we developed the stub to recursive case. So this is the question of doing strict ZOT, which is where both parties are configured to only allow the transfer over a ZOT connection. And then the question is, are there use cases for other scenarios? Now, obviously, if you don't want privacy, you could choose to opportunistically use ZOT, but you have no guarantees. But the question is there a use case for allowing fallback to TCP? And the place we see that use case appearing is really during testing and rollout. We think it could be convenient if a primary could be configured to allow each of its secondaries to either do strict ZOT or allow fallback to TCP. And that would be helpful because it may be that the secondaries get incrementally upgraded to support ZOT. But obviously that allows downgrade, so we can't see as much value in allowing secondaries to control whether the fallback happens or not. So we will add text on this in the next version of the draft. Something else that we'll probably add text on the discussion is around the configuration of the certificates on the server. Now, because we've introduced an ALPN, it's now easy to see that configuring certificates can be split if you choose to. So you can choose to configure certificates on your primary that are used only for zone transfers, and then any future credential management around other encrypted forms of transport can be orthogonal to the ZOT certificates. And there's been a little bit of discussion around whether or not it's useful to have a single certificate with possibly multiple SANs, or are there cases where operators might want a certificate per zone, support therefore selected on SNI. So we'll add a bit more text, but if people have specific use cases and thinking on this, again, we'd really appreciate hearing about that. We also touch on using mutual TLS in the current draft, and we've had differing opinions on whether this makes your life easier or harder operationally. And that's probably quite context-based as to whether you operate all the servers involved in a transfer or not. So more feedback on that specifically would be appreciated as well. And the last thing that isn't in the current draft, but we will add in the next, is a discussion on the use of name compression. Most of the implementations that we've looked at use name compression on transfers, but the use of name compression limits a packet size to 16K because that's as far back in the packet as a compression pointer could look. So we have an action to investigate whether or not, for ZOT, suggesting an option to disable that is useful in order to have maximum size packets for the transfer. So that's very much an open question. Last slide. The specification is maturing. Please, if you have the opportunity, please provide a review on the list because we would very much like input on this. We are starting to think about implementations. We're starting work on a patch for NSD, and we've also had some very early and constructive discussions with ISC on support in bind for this. We also think that a future interop on this would be really useful to iron out probably some of the more minor issues, but to get everything moving smoothly. So that's something we'd like to think about and potentially plan. We are aware of a demand from a number of organisations who would like to deploy this. So there is a real world need for this. And we are hopeful. We intend to update this draft regularly and incorporate feedback from the implementation that works. And we would like to think we would be in a position by around IETF 109 to progress it to working group last call. We don't think we're there quite yet. We have a few open questions yet, but that's what we're aiming for. So with that, that concludes the presentation, and I believe we have people in the queue and some questions. Thank you very much.
We do have some questions. First one up is Daniel.
This is Daniel Kahn-Gilmore from the ACLU. Thanks for doing this work. I just had questions about using ALPN.
Mm-hmm.
Given that ALPN is in clear text part of the TLS handshake, it's definitely identifying itself in a different, specifically as a zone transfer, in a way that a connection that could appear to be a normal A dot for, I'm hand waving over here. But if someone, so I'm wondering whether you have any thoughts about the risks of distinguishability between ZOT and other potential authoritative DNS over TLS, and also if you think that we will get to defining authoritative DNS over TLS in the future, what are the impacts of having moving the zone transfers into a visibly distinct category from that? Does that make sense? It looks to me like if we imagine a world where we have authoritative, DNS over TLS to the authoritative, all of a sudden now we've leaked that one connection is a zone transfer and another connection is not.
So that is a disadvantage, but some initial work looking at the nature of the traffic might indicate that even with padding, unless we do additional work, it's going to be relatively clear that one of them is being used for zone transfers. So I think we wouldn't have to worry about just about the ALPN. We would have to worry about using padding and timing to make the traffic indistinguishable, which I'm not sure there's an appetite for that.
It sounds expensive for sure.
And there's also, there's also the possibility that it's possible to determine which name servers host zones by, doing an active query on the DNS. So distinguishing as to whether something making a connection is a recursive and or a primary that's hosting a zone is, again, there's sort of a question as to how useful that is. So we've we've considered the primary threat model here protecting the zone contents, not necessarily protecting the idea that two entities are engaging in zone transfers. If that answers your question.
Yeah. So just to highlight for folks who are thinking about this, one of the reasons you might want to hide the fact that this is a zone transfer is because you don't want an adversary to identify where the secondaries are, or where this distribution is happening. I'm not sure that's particularly plausible. But the other reason to try to detect a zone transfer would be to prevent it. So a network attacker who can identify that something is a zone transfer from the handshake could keep it from happening, whereas a network transfer that is only identifiable after analysis of the traffic, you wouldn't have been able to prevent at least some of the zone transfer from going on. So I think there's a slightly different trade-off there depending on what your concern is. Anyway, I just wanted to put that on the table to make sure people are thinking about it. And is the idea here that if we do define an ADOT mechanism, that having a ZOT ALPN would somehow preclude doing zone transfer over a more generic ADOT?
Absolutely not, and I thought I said that on one of the slides. It doesn't. What we're saying is this will be one mechanism that can be used to do zone transfer standalone, and that there could be a future development of mixed mode. So yes, you can use one connection to do whatever exchanges you like, and that may have no ALPN, it may have a different ALPN. Our goal at the moment is really to decouple ourselves from any dependency there. So we don't believe we're precluding it, but we think there's a solution that we can move forward quickly to here that is decoupled from any other implementation or deployment of encryption on authoritatives.
Cool, thanks.
Okay, thanks.
Hello?
Peter.
Yes, hello, this is Peter at PowerDNS. I'm also here to talk about the ALPN.
Okay.
One problem I see with it is that you limit to XFR, IXFR, SOA.
Yep.
PowerDNS, for example, might also do NS queries as part of an auto-provisioning mechanism we have. Further, if you don't do the ALPN, then any name server today that has decent TCP handling becomes compliant with the drafts by just adding a TLS proxy in front. With the ALPN, suddenly new code has to be written, and you have two code paths that handle different RR types in queries differently. And I imagine that eventually we'll have some ADOT thing that might not need to be separate from ZOT.
So you're right about the proxy question, and it's something we don't discuss in the draft, but it is an issue. But that's already an issue today, in a sense, that some of the specs for TCP and TLS might be subtly different, even when we have encryption to authoritatives. What we didn't want to do was to force authoritatives to answer queries over an encrypted connection if it hadn't been implemented or supported. So it's the swings and roundabouts in those two discussions. We've gone with the ALPN because we feel it's a narrower spec and it's slightly cleaner, and there is absolutely nothing to stop a secondary opening any other connection to that primary to do any other query at once in clear text. Like, that's not prevented. We're just saying that we want to guarantee the encryption for the actual zone transfer itself.
Yeah.
So I take your point, and we did debate back and forth about this, and we've jumped for the ALPN, but there should probably be a bit more discussion in the draft about the rationale. That's certainly true.
Yeah, because I imagine if we had ADOT already and you did this draft 1 year from now, there would be no LPN because you had no reason for that. But
Very possibly.
right
but
now
what
it's the future and that we can predict.
I mean, so one thing that struck me when I sat down to do this is I don't know when that spec is going to appear. I don't know what form of credentials are going to be involved in authenticating that connection. And I don't even want to count on it being over TLS. It could be that we take long enough that we end up switching to Quick.
Yeah.
And we think we can get Zot implemented, we can nail down the spec and we can get it implemented and pushed out. We'd like to be thinking the end of this year, and removing the dependency on the A. discussion is attractive when you look at it from that point of view.
Reducing the dependency and preventing this from limiting the scope of what happens there. Yeah, I do get it.
Yeah.
All right, thank you.
All right, thanks.
Hi, Sarah. Nice work. You talk about the draft a little bit about rate limits and stuff like that. I wonder if it's worthwhile considering things like TLS session ticketing and session resumption stuff. And maybe that has to wait until we've got some interoperability results, or perhaps we have to wait until we have the EDOT stuff a bit more mature. I'm just wondering if you see any value in saying anything about this at this stage. Maybe it's completely premature.
I think it's a little premature, and I guess I'm wondering what would be different for this as opposed to any more general guidance we developed, even for stub to recursive or recursive to authoritative. Off the top of my head, I can't think of anything specific to the zone transfer that we would need to discuss, but it's certainly something we should think about. So yeah, thanks for that comment.
Thanks, Sarah. I was thinking particularly, for example, if you've got a big registrar that's got hundreds of thousands of zones under management, and could have multiple zone transfers going on to try and keep everything consistent inside the cluster.
Yep. Yeah, I mean, we talk about generally, reusing persistent connections, using keep alive to keep them open, minimizing the number of handshakes you have to do. So, but I think that sort of advice is becoming quite general across all the scenarios for DNS.
Okay, thanks, Sarah.
Thank you.
Jonathan.
Hi, John Reed, Akamai. I just want to say I really like this, and I'm actually going to come out in favor of the ALPN because I see this, and I think you've made this point, I see this as both an extension of AXFR itself and moving it to TLS. There's a lot of shortcomings in AXFR today. Having a clear indication to the server that I want to do Zot, and that means you need to accept all these queries, you need to behave in this way, goes a long way. And I think there's some value there. I take, Dan and others' concerns about signaling, but I'll also note that, in our experience as a large operator, a lot of customers have what they call hidden masters, where they have very strict IP ACLs. So any traffic to them, there's nothing else talking to them except zone transfer. So it's pretty clear what's going on there. So I really like this. Thank you.
Thank you.
Hi. So what happens right now if I just kind of open up a TCP connection and do a zone transfer? I guess the purpose of the LPN is to distinguish two protocols which cannot be otherwise distinguished on the wire by the content, right? And so right now I can open a TCP connection and do whatever the heck I want, right? So why does that situation need to change now?
So what we didn't want to do was have a requirement that if an authoritative was going to support Zot, it had to be prepared to answer any other query over the same connection. When it might not have any, it might not have any declaration or published intention to support an encrypted protocol yet, because what that might mean is that then recursives might just start routinely using TLS to ask questions of authoritatives, and And then the operator, the authoritative, has to make some choices about whether it answers them. So it indirectly forces them to support DOT. And we don't want to put that requirement on them right now, because there is no spec that says this is how you do DOT between recursives and authoritatives. It's all just very implicit by the fact that there's a stuff to recursive spec. So, well, you might not think it's a bad thing. We don't want supporting transfers over ZOT to have any implicit knock-on effects that we can't anticipate.
Yeah, I guess I still don't understand, because like they can just refuse to answer those queries. This is detectable at the application layer. So I mean, this is like saying, I mean, I guess like let me give you a analogy, right? Just because I support GET in HTTP over TLS doesn't mean I'm required to support random new method types that were invented afterwards. And the same thing is true here. There's no specification for these queries, so not required to support them. And why don't you want to be distinguished why does what have to happen be refused the TLS layer rather than refuse the application layer?
So we think it's clearer, and also there are other restrictions on, for example, doing zone transfer like IP-based ACLs or TSIG, and we felt that operators having very clear mechanisms to choose who to accept requests for zone transfers on the earlier they can in the interaction is a good thing in terms of controlling access to zones.
Yeah, I mean, I just don't think ALPN was intended as kind of like general purpose interlane mechanism. So,
so are you suggesting that we shouldn't have an ALPN and this document should require an authoritative to answer any query over a TLS connection, when actually all they want to do is support zone transfers?
No, I'm suggesting you should use the ALPN dot, and that you should refuse to answer those queries over you should refuse to answer those queries the DNS layer if you don't want to.
Sorry, we use an ALPN dot?
Of dot, yes.
And then the server refuses which queries on which basis?
Any queries it doesn't want to answer at all. I mean, that's what you do. What would you do? So I mean, say you only accepted zone transfers over TCP now. Say the only thing you accepted over TCP now was zone transfers, right? And you didn't want to take arbitrary queries. What would you do? You'd respond with some sort of error. And so I'm saying that you do the exact same thing. I'm saying that the TLS just displaces TCP in this case. I mean, like imagine I only wanted to answer queries for A records. We wouldn't have dot -a. So I mean, dot just isn't a general purpose policy. I mean, ALPN isn't a general purpose policy enforcement mechanism. It's intended to distinguish between things that to have negotiation at the handshake layer for things either have to happen prior to application transmission for one reason or another, or to tell the network what's going on. But that, as DKG points out, the second is undesirable in this case, and the first seems unnecessary. I mean, I don't think it's a crisis, but it just seems like unnecessary proliferation of ALPNs.
Okay. I mean, it's not. I mean, we still have concerns around requiring authoritatives to answer any queries when they may not have a reason to, because then you're going to have sort of implementation specific behavior around refusals, which is less consistent than having a very tightly modeled communication.
But again, I guess this goes back to my, I mean, I suppose.
I take your point. I take your point, and I think there are weaknesses in both approaches. So yes, it is a discussion we need to have about which one we should plump for.
Okay.
Yeah. Thank you.
This is DKG again. So I'm just trying to think through what the different trade-offs here, and so one of the things that I'm hearing is we don't want to require authoritative name servers to handle arbitrary requests from recursors over DNS over DOT, because maybe that's too expensive, maybe they don't want to manage that state, maybe there's a bunch of other reasons why they don't want to have to do that.
Yeah.
And we know that in practice, a lot of authoritatives are refusing certain types of requests from the general public anyway, right? So, for example, in today's network, many of the limitations on AXFR are IP-based limitations, right?
Yeah.
You deploy a primary, you just say, I'm just not, if you make an AXFR request and and I don't think you're a configured secondary, I'm just going to say nope. You could apply those same limitations, like IP-based limitations, to the 853 listener. If you don't want to answer but to anyone but your secondaries, you could just not answer on TLS port at all. So in some sense, it sounds like there is a simpler approach, which is to keep to use the dot, and then Sarah, I think your concerns are real. That the refusals or rejections themselves are going to be scattered and non-uniform if we don't give good guidance. But maybe what this draft can do is to say, if the intent is to only provide zone transfer over this particular interface, here is exactly how you should do the rejection, so that we can have a clear signal if a recursor mistakenly tries to use zone transfer over TLS for general purpose DNS queries. They can say, aha, I got it. This is, I was trying to use it for generic DNS over TLS from recursor to authoritative, but that's not what they're doing. If we could define how the failure works in the application layer inside the TLS connection, then we don't need to have the ALPN proliferation or public visible signaling that this is ZOT instead of DOT.
I mean, that certainly is an option. I think our original thinking was that then becomes potentially more algorithmically heavy, because you're rejecting on a connection on a per message basis. Whereas if you have a clear signal that this connection can only be used for this, then it's very clear what queries are allowed and what queries aren't. So that was kind of our thinking of the ALPN being useful, as opposed to trying to develop something that everybody's going to implement differently about managing different queries on different connections. But I take your point, and we'll certainly take all the comments on board from today and revisit the use of ALPN.
Hi, this is Petr Pacek. I'm in agreement with two previous speakers, and I would say that having special ALPN is too much overhead and it's too complicated. From my perspective, it would be enough if the draft for the ZOT said, you have to handle these types of queries over the TLS. So let's say SOA, query, notify, and zone transfer itself. And for the rest, either you can reply, or if you want to support like unspecified DOT queries, or you can send back refused with whatever, extended error code or something. And I think that that's perfectly fine. Doesn't require any ALPN, and any authoritative server which decides to answer also any other queries over DOT can do that without breaking the standard. Because honestly, from my implementer perspective, there is no additional cost of handling other queries. Once you have the TLS stack inside, I don't see a reason why not to answer other queries. The problem is the discovery, not handling the queries. So
I mean, I'm not sure all operators of all authoritatives would agree that they would be happy to just open up their servers to TLS queries. So
that's understood, of course. If you are concerned about performance, then you might close or limit the access to the TLS to some subnets or something. But anyway, if you are concerned about performance, you have to limit to access to TLS on the IP layer anyway, because doing lots and lots of TLS handshakes is perfect attack vector from the performance perspective. So, well, yeah.
So yeah, there's certain
the
considerations
most
there.
expensive part of TLS is the handshake. Once the handshake is done, it's cheap. So, if you are concerned about performance, you have to cut it earlier. And if you are not concerned about performance, why would you limit DOT to like 3 query types?
We were also looking back at what 7766 said, which was trying to use separate connections for separate purposes to make managing them easier. So if we say, maybe this is the right thing. If we do say any connection can be used for anything and traffic is all mixed, then we're slightly going against that model. And I think you might end up with a lot of configuration options needing to be available so that each operator could tune exactly how they behave on a TLS connection to exactly how they wanted to do it. And that was what seemed actually to us quite an overhead and likely to lead to inconsistencies. And then maybe each client has to cater for a whole range of different behaviors from a primary. And that was why we kind of moved towards, well, it's simpler if what can happen on this connection is limited and clear. But I do take your point. Thanks, Peter.
Okay, thanks.
Eric Nygren, Akamai. Is there a reason not to just use SNI for this? Because that would mean that you could use the name of the service endpoint as a thing to identify. And if you want to have both on the same name, you can. But if you want to have a service endpoint that is just for primary DNS zone transfers, you can move that onto a separate name, and that separates off the endpoint naming from the IP addresses without necessarily needing to get into what are the underlying protocols that get used.
It's an option, but then would we allow any queries on something that came in with a specific SNI or not? In which case we're still implementing the same underlying model of restriction, and that's possibly a different mechanism to do it.
Yeah, because I think the thinking there would be that if you had that, from a configuration perspective, you can configure up on a separate host name and then refuse queries that come in that are misconfigured.
Okay, yep, so I was thinking about, thanks.
Yeah, so I think, certainly if what you want to do is differentiate service endpoints at the it negotiates the client which services is allowed to do, then ALPN is a reasonable time to do that. If your hypothesis is that the client is, for instance, going to connect with with ALPN's ZOT and DOT, and then based on what the server says, it will either only issue zone transfers or will issue all queries, then one might imagine doing that. I think the problem there is going to be that this is a very narrow signaling channel, and so that only supports a couple of profiles, and so how does if the server answers, if what the server wants is them in separate channels and the client offers ZOT DOT and then the server says ZOT, then how does the client know that if it opened up a new connection with just DOT, that would work great? I think that if we want that kind of policy, we're going to need some way to actually express that policy, whether that's out of band or whatever. And it seems like SNI might be a wider channel because it doesn't require ANA registration for every new policy endpoint. The other point I think that's worth making is, what would you do in this circumstance? What happens if I offer ZOT and the server says ZOT, and then I start issuing other queries? So what happens?
The server will refuse those queries.
Okay, so I guess then this goes back to my original thesis, which is we need to define how that happens, and we might as well define and then having the ALPN is duplicative.
Okay, so we're trying to decouple imagining any future deployment scenario from something we want to deliver in the short term. So that's one of our motivations here. And I think with the ALPN, it can provide a mechanism to do that, but I appreciate that there are some disadvantages to it. I think we do, yeah, so we'll take all the comments from today on board and go back to think about it. I mean, I think if we don't use ALPN, I think there's a tuning problem between implementations and between deployments, because we could have inconsistent behavior. Maybe we can achieve the same thing with SNI, and that would be better. We'll certainly go back and consider that. But I think I can imagine if I'd come today and said, we're going to say if you support ZOT, you have to answer anything over DOT. Everybody okay with that? I imagine there actually would have been a reaction against that. So it's really great to hear from both sides of the argument, and we will take all this feedback on board. Thank you.
I want to be clear, I'm not saying that you have to support everything over DOT. I'm saying it's undefined behavior that the specification doesn't list anything about.
Yeah, and we thought ZOT is a constrained enough use case that it's straightforward to define what we can do within a very specific context without impacting on any other service requirement for that authoritative server. So it depends whether that's more useful than having the more general solution. That's the decision to make.
Thanks.
Okay, thank you. Okay, I have a feeling there's a whole ton of discussion in chat, which I am not able to keep up with, so I will certainly look at that afterwards.
All right, thank you, Sarah. Now we'll move on to Peter and his signaling document.
Let's see, there's the audio. I don't think I'm getting video. Do you need to permit that? Oh, I did not permit the camera. All right, fine. Let me grab my notes. So my name is Peter van Dijk with PowerDNS. My co-authors are Robin Geuze and Manu Bertel. Before I present this, I want to go back to something Paul Hoffman said in DNSOP about there being 2 or 3 current drafts for DOT and related things, no coordination, authors pushing their own draft forward, etc. And why don't we discuss requirements first? DPRIVE does have a requirements document. I imagine that the next revision of that will take some great input from all the discussion we've had on this draft and perhaps on Tim April's NS2 draft. And I don't want to give anybody the idea that I am trying to push one draft through at the cost of any others. In fact, when I told Tim we use DS to signal against downgrades, I meant maybe this trick will work for you. I do recognize that we have drafts that appear to be competing, but when I look at NS2 more closely, I feel that actually these 2 drafts are almost orthogonal and might make sense together. We do understand that our draft solves the problem very narrowly and comes with some management difficulties that can be a problem for certainly large deployments. All right. Tim? Yes. Okay, this is a review that Petr Spacek gave on the list. It is the intro that we should have written for our drafts. Our proposal enables DOT without any extra round trips because you already get the DS record from a delegation. The proposal is downgrade resistant. We have the potential to close all clear text leaks in the optimistic assumption that at some point TLD operators will also do this. I'm not too worried about the route. We have excellent deployability, we feel, because we use existing records. And CDNSKey makes management from the child side easy. Some more positive reviews and then 2 other comments that I will address. People say this is protocol abuse, and I agree. we went at this not even from a use case, but from these are the tools we have. The only authentic data from a child in the parent is the DS record. And as such, that is where the things have to go. Tim, the slides keep dropping in and out for me. For anybody else?
There's a bunch of storms going on and I'm having problems. I'm just telling Brian he may have to step up here. So I apologize.
All right, well, I'll carry on. Then the other comment we got is you should be using TLSA. And I get that. We have wedged TLSA into a different shaped box, and NS2, NS2T does something similar. But I have trouble imagining a TLSA-based solution to this problem, however we define this problem. I would love to see a draft that uses TLSA. I could even imagine that a TLSA-based draft still uses our DS trick to prevent downgrades, but does not try to fit all of TLSA into a DS record. We do not want to change this draft to use TLSA. We think we have a very simple proposal, and anything using TLSA would be a different proposal. That said, I don't feel any drafts should be competing. It's possible that there are multiple sensible solutions to multiple sensible use cases, as Paul Hoffman has also mentioned. Next slide, please. So the history of this, about a year ago, Manu Bretel presented at IETF 103 in Prague. He imagined a DS PKI record type that would sit in the parent like DS does, and that basically takes the public key info from the server, sticks it in the parent. So you have, like with our proposal, no round trips, no downgrades. It's a simple protocol. There's no extra lookups, which I thought was a very neat idea. But of course, this not being DS, you can't deploy it until authoritative developers and operators and registries update their software to do this. We spent a lot of time puzzling how to fix this. And this draft I'm presenting now is what we ended up with. Next slide, please. Yeah, I'll describe the protocol from the perspective of the resolver, and presumably then it should be clear from any perspective. When a resolver is resolving a name, it might go to the TLD servers, to the .com servers, and get the delegation for example.com. This is no news, of course. This delegation has some NS records that have names, and crucially, these names are not authenticated. There's no DNSSEC signature over those. The DS record is the one thing that is authenticated. Next slide, please. The resolver takes one of the name servers, it connects to it, port 853. We don't currently have an ALPN. I hadn't even realized that it was an option until I read the XOT draft earlier today. The resolver connects, negotiates TLS, does no certificate checking. It receives the public key from the authoritative. Then it constructs a DNS key record in memory. This is not a record that appears in any zone. In this DNS key, it sticks the subject public key info, and the other three fields are set to constants. Flags I'll come back to later. The protocol is 3 because this is DNSSEC, and the algorithm will presumably, hopefully, be assigned by ANA. Next slide, please. Now we have a DNS key record in memory, and we can hash this like a validator would always already do for any DNS keys that are actually found in a zone. So in this case, because the DS record said DITE is type 2, SHA-256, we hash with that, and hopefully we come up with the same DS record that we found on the delegation. Next slide, please. So if we match that DS, we are done. We have a safe connection to a name server, for example.com. We haven't validated the name of it, but we have validated that we are connected safely to a machine that has a public key that has been provided by the zone owner. If no DS is matched, we can try another server. Perhaps there's a server in the DNS set that is not in the DS set. If we run out of servers eventually, then we cannot resolve names. That is where the downgrade resistance is. Next slide, please. So we are safely connected. We can start issuing queries, and this slide says any observer will only know the name and IP of the name server we connected to, at least until ESNI becomes a thing. But I spoke to Ralf Dolman of Nelnet Labs early this morning, and he pointed out two things. One, you can't do ESNI because you need DNS to do that. But two, why are you sending an SNI at all? DNS over port 53 does not transmit the name of the server it wants to talk to, so why would we do that? So I think in the next revision of the draft, we will clarify that you send no SNI at all. Next slide, please. We have some open questions. These our set of questions is not complete. I'll mention one afterwards. The first open question is about DNS key flags. Obviously, these are not zone keys, and obviously these are not secure entry points. We had some brief discussion about whether pinned and validated DOT would be enough for an AD bit, but that doesn't make sense because you cannot check if your forwarder used TLS to get the data for you. So we'll leave the AD bit to DNSSEC proper. So 0 makes the most sense, but in a small informal survey of some registry operations, we get a strong impression that many registries demand that you use 256 or 257, or in some cases even demand that you use a flags value 257. Given that we do not mark the algorithm for zone signing in the IANA registry when it is assigned, we feel that this will not give a functional problem. So in revision 01, we went with 257, but we could go back. We feel that 257 might make deployment easier, but 0 will be more correct. So we're undecided on this. Next slide, please. So this comes back to the protocol abuse and some related questions. Below you see the template for the IANA assignment as we put it in the draft. And this would be the first DNSSEC algorithm that has zone signing, no. And then you end up with a bunch of questions that come down to what do non-DNSSEC DSS even mean? One registry operator pointed out that in Whois, they mark a domain as being signed if you have any DS records. But if you imagine a domain that only has a .pin DS and no other DSs, that domain is not DNSSEC signed. So does that mean that the Whois software will have to have a list of DNSSEC algorithms marked for zone signing and some not marked for zone signing, etc. Similarly, the CDS, CDNS key transition rules assume that all your CDS or CDNS keys are for DNSSEC, and also prevent doing this on zones that are otherwise unsigned. We haven't figured this out yet. We need to look at the CDS RFC some more to figure out the right interactions here. Next slide, please. Implementation-wise, we have written some code in Python and Go and C++, just to show that the concept can work, and also to show that if you have a decent DNS handling infrastructure, so you already know how to generate DNS keys, digest them into DSS, etc., that this is only 10 or 15 lines of code, assuming your resolver can already do TLS. Let's see, next slide, please. Right. There is one open question that I forgot to put in these slides. Paul Wouters suggested that the DNS key or DS that pins your connection should always be visible in the child, so that you can prevent certain interception attacks by the parents. I'll be honest, I do not understand his threat model, but for now, that's an open question for us. Let me check my notes. That is all I have. Thank you.
Thank you, Peter. Anybody have questions they want to talk about now?
Well, Paul is not presenting. He left.
Right. Yeah, Paul had to drop off and is not going to be able to present his slides. So I think what Tim and I want to do is we just want to put up. So Paul's slides are in the meeting materials, so everybody can take a look at them as you need to. But I think that the bigger thing that we wanted to do was kind of point out a couple of points that Paul was making in his presentation. So I'll give one last chance for anybody to ask Peter questions about his draft. Otherwise, we're going to go to an open mic session to talk about the ideas that Paul was going to present. Okay, thank you, Peter.
No problem.
So rather than Tim and I trying to articulate Paul's points in his slides, I think one of the things that came up in the DNSOP session that I heard, and I'll let maybe Tim or one of the other DNSOP chairs chime in here, but there are questions about the use cases and how they may differ across the spectrum and how that might actually affect the design. So I think the big thing here is whether or not there are specific sets of use cases that we want to focus on as a part of this, and how do we reflect that information into our work. So if we get away from specific design criteria or design approaches, are we interested in a specific set of use cases? And this is where I would also point out that we've been doing some of the phase 2 requirements work. So what I'd like to hear is more of a feedback on what things does DPRIVE need to do in order to keep those things moving in a positive direction and solve the problems that people have. Puneet?
Hi, this is Puneet here from Google with my Google Public DNS hat on. Can you hear me?
Yes.
Hi, can you hear me?
Yes, we can hear you.
Okay, great. Yeah, so one thing I think at a high level I would want us as a group to think about is this proposal has the nice property that it prevents downgrade attacks, which basically assumes an active adversary. For simplicity of deployment and all, we should see if how acceptable the use case for a passive observer on the network where all they can do is observe the packets and be able to do a DOT upgrade in that scenario. Basically, the extra complexity of doing what is proposed in this draft or similar work versus being able to just do opportunistic upgrade and the ease of deployment of that.
Okay. Ralph?
speak now?
Yes, you can. Go ahead.
Okay. Yeah. So this is Alfredo from Akamai. So Peter said that he would see kind of multiple use cases leading to different sort of proposals how to do this upgrade. What I think, I'm not agreeing with this, because I think having multiple solutions in the servers on how to discover and use an encrypted service is just adding another layer. And I mean, we currently have Peter's draft, there's NS2, and then there's the adaptive DNS draft. And they're all trying to do different things when it comes to the actual kind of how do they achieve things. But the end goal of them is kind of to have a secure connection between the recursive from the authority, well, and the DF may be a bit even from the end client. And I think we should do something like a comparison. What are the pros and cons of the draft, and then pick one and not try to do 2 or 3 things at the same time.
So if I were to put you on the spot a little bit, do you think that there are gaps in the requirements document that we need to resolve in order to ensure that we can move forward in the direction that you're proposing?
I haven't read the requirements this time around. I've read it around, I think, with the last meeting we met in person, so I don't think there were much gaps in there. There is I mean, we need to come to a conclusion where do we want to go. But I think the requirements and all of the drafts that are, I mean, out there, I think fulfill the requirements, but we need to pick one.
Okay. So that's a useful comment. And I think Tim was going to chime in on one of the DNS or the ADD drafts that might be relevant here as well.
Yeah, sorry. And Ralph's right, though. I think before you pick one, you want to try a bunch of stuff to see which one seems to work, sort of thing, right? But
no, I'm not against experimenting.
Yeah, experiment's good. Yeah. Brian and I have talked about this with Eric. It's come up a couple times, and it's come up with the DNSOP chairs as well. Puneet and Paul have a resolver info draft in DNSOP that's kind of sitting, waiting for ADD to do something with it. But they also have a auth server info draft that I was pushing them. I felt that would be much more relevant. And even Eric pointed out that there is probably some interesting stuff there if we have something like auth server info where you can actually query the server and get details back as to what it can do, right? And then that may actually help in some of these sort of use case scenarios. And we wanted to see where those are going. Right now, we're not sure where they're going in ADD. We need to keep poking the chairs to find out what's happening there. I think if not, they may end up, I've been talking to Paul and Puneet about moving them back to DNSOP and sort of aggressively coming to consensus on stuff is probably the best way to say it. And it'd be interesting to get feedback on some of that stuff too.
I'm not sure if auth server info will help, because normally we discover stuff while we traverse the tree, and that would be something we would have to in parallel. But I mean, I don't know the draft, so.
True, that is true.
Okay. Any other comments that people want to throw out in relation to getting this moving? Puneet's back.
Hi. One other observation I have after reading a bunch of the drafts in the various groups is that I think there's a requirement or basically we are evaluating the proposals against, does it need an extra query? I think, and please correct me if my understanding is wrong here, what the NS revalidation draft from Shimon and Paul Wixie is proposing is that when you get the delegation from the parent, it requires the resolver to anyway go to the child and re-query the NS record so that it has a consistent set of information. So if that becomes RFC and resolvers are required to do that extra step anyway, the benefit of avoiding extra query goes away in my mind. And then we could piggyback some of this information along with the query to the child.
Right. Tim, do you have a status on where Schumann's document stands?
Got some changes they want to make, but it's a pretty straightforward document in terms of size and length and stuff. I was hoping if I could motivate the authors enough to see if we can actually move that along, much like the Mark Andrews draft. They're straight to the point kind of thing. So I don't see why not. It's a question of how we motivate the authors to do updates and stuff.
Okay.
I would like to react to Puneeth's remark because the delegation revalidation draft says that the resolver is supposed to do query to the child, but the query is asynchronous to the original query. It's like the resolver will not block the client query on answer from the child. So it doesn't introduce any more latency from the client perspective. So I don't think that the argument is valid because it is not increasing latency. Waiting for TLSA from the child would increase latency for sure.
Oh, I'm on.
Yep.
We're waiting for Schumann, who is in the chat but doesn't have audio. He says we are working on updating the draft.
Oh, excellent.
Willem is in the chat suggesting a hum for adoption of ds.signal.
Well, we can certainly give that a try. So what I'll do is I'll ask two questions. I'll ask for a hum on adopting the document, and I'll also ask for a hum on not adopting the document.
Since DNSOP has been clarified what the soft hum and not humming at all mean, effectively.
Right. So my understanding from the various meetings I've been in that if no sound is picked up, they assume a medium hum, which throws the algorithm a little bit off. So as many people as possible need to express an opinion.
All right.
So the first question will be, is the working group interested in adopting the draft?
Peter's draft DS.
Yes,
Yeah.
Right. I will start that now. Okay, so I don't know how many of you actually hum for the 35 straight seconds, but we ended up with a level of forte to adopt. The inverse question.
It's not actually a physical hum, it's a button in meet echo. People are not actually sitting at home humming.
Right. So now we'll do the hum for not adopting this document. and I'll start that now. Okay, and the results for that hum were a piano. So not a whole lot of difference there. So Tim and I will formulate these questions and actually put them out on the mailing list so that we can get further input on it. And please do keep providing feedback to the document authors. I think they've been getting a lot of good comments back, and I don't want to see that keep moving. And with that, we've reached the end of all of our agenda items. Are there any topics that people want to bring up or raise? It looks like we have about 14 minutes of meeting time left. Okay, well, thanks everybody for participating. Tim and I are going to pull the minutes together and get those uploaded. We'll work on getting out a question to the working group about the adoption of DS dot signal and pin, and we will continue working with the authors on the expert over TLS and the 7626 biz revisions. Thanks everyone for participating, and hopefully we will see you soon in person somewhere. Thanks a lot.